All right, everyone. So here is a short video on LCM, lowest common multiple, and GCF. Remember, this just accompanies the full lesson that you can find in the full lesson playlist for Pre-Calculus 10, but these shorts are just quick couple question examples. So for this first one, we're looking for the lowest common multiple, which means, remember, a multiple has to be bigger than the numbers because multiples are bigger than the original. That is the whole idea behind a multiple. And if we know what the numbers are made up of, i.e. prime factors, we know exactly what we need in this number we are creating. We are creating a lowest common multiple. Okay, we're creating a number that does a multiple of all of them. So if you break these down into primes, 15 is 3 times 5, which means in order to be a multiple of 15, we need to have the factors 3 times 5. So our lowest common multiple at least has to have that. In order to be a multiple of 18, which is 2 times 9, which is 3 times 3, we need to have factors 2, 3, and 3. Now, if you look, we already have one 3, so we just need another 3 and a 2. Because now we have a lowest common multiple that is a multiple of 18 because we have 2 times 3 times 3 and then times 5. And we have a lowest common multiple that is a multiple of 15 because we have 3 times 5 and times 3 times 2. So all we need now is to make sure we are also a multiple of 24, which is 2 times 12, 2 times 6, 2 times 3. So what we need in order to be a multiple of 24 is we need 1, 2, 3 2's. And if you look at your lowest common multiple right now, we only have 1, so we need 2 more. And we need a 3, but we already have a couple 3's in there, so we're totally fine. So what you have here, 2 times 2 times 2 times 3 times 3 times 5, is the prime factor breakdown of the lowest common multiple of those three numbers. And if we multiply those things together, which you don't have to do, but we will here, you get 360, which is the lowest common multiple of 15, 18, and 24. So by creating it using using prime factors, we are in essence creating a number out of prime factors that we need. So let's look at another. Lowest common multiple of 27, 30, and 36. So it's the same process. What is 27? Well, it's 3 times 9, which is 3 times 3. So it means I'm going to need 3 times 3 times 3. Well, what's 30? 3 times 10, which is 2 times 5. We're going to need a 3. I already have one. But I need a 2 and I need a 5. So I need a 2 and I need a 5. And then what's 36? Well, 6 times 6, 2 times 3, 2 times 3. So I need 2 3's. Well, I already have 3 of them. I need 2 2's. Well, I already have 1 of them. So I really only need 1 more 2. And now I've created a number that is a multiple of all 3 of those numbers. And it is the smallest possible one. And if you multiply these together, I hope I did this right, you get 540. So it's a really awesome way to get a lowest common multiple by creating one out of essentially the building blocks of factors that you need for each one. So now let's look at greatest common factor. A lot of people mix these two up because they see the word greatest and they see the word lowest. So they just think big numbers and small numbers. But really the word multiple is the most important because it has to be bigger than, if 36 is one of our numbers, 27 and 30 have to at least be bigger than 36 in order for a number to be a multiple of 36, right? So it can't be small number. And then we see the word factor. Well, now we're actually looking for factors, not multiples. So these ones are smaller. So now again, let's do the factor trees. 36 is 6 times 6, which is 2 times 3, and 2 times 3. And for this, it really helps to look at it like this. 36 is 2 squared times 3 squared. And then for 48, we have 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So for 48, we have 1, 2, 3, 4. So we have 2 to the 4 times 3. And then for 60, well, we have 6 times 10, which is 2 times 3, and 2 times 5. So we have 2 squared times 3 times 5. And it's nice to line them up like this because what we're looking for is we're looking for common factors. So if you put a column around each of the prime factors that appear in the numbers, Each column needs to be full in order to be common. So we already know that the 5 has no bearing here because it's not common in 36 and 48. 2 and 3 both is, but the question is how many of each? So in this case, it's not the largest number, it's the smallest amount of times you see it, because for 36 I have a 2 squared, for 60 I have a 2 squared, but for 48 I have a 2 to the 4. So really the only thing that's common though is 2 to the 4 means I definitely have 2 squared. So for my greatest common factor, I know that they all have 2 squared in common. But then if I look in my 3's column, they all have a 3 as well. Thing is they have 1 3, 1 3, and 2 3's. So how many 3's do they have in common? Just 1. So my greatest common factor is 2 squared times 3, which is 12. So 12 is my greatest common factor. The columns are super helpful in this one. I'll do one more here. So 32 is 2 times 16. Remember, you can break these down however you're most comfortable. You could have done 4 times 8. You could have done a couple other ways. So here we have 2 times 4, and then 2 times 2. Well, so that means 32 is 2 to the power of 5. Now, that should almost set off alarm bells right away, because 40 is 8 times 5, which is 2 times 4, which is 2 times 2. So for 40, you have 2 cubed times, leave a spot in case there's a 3 in my 60, but you already know that this 5 isn't going to be common because it's not in 32, so really it doesn't even matter. No bearing on my greatest common factor. And then my 60, well yeah, 3 times 20, 4 times 5, 2 times 2. So for 60, I have 2 squared times 3, and then yeah, times 5, but we already know the 5 column doesn't matter because I don't have a 5 as a factor for 32. And then for 40, I also have a 3, but I don't have a 3 as a factor for 32. So my 3 column really doesn't matter either. The only common factor they have is a 2. And the question is, how many do they have in common? They only have 2 in common, because here I have 5 of them, but I only have 3 of them. So if it was only those 2 numbers, 2 to the power 3 would be my greatest common factor. But when I bring 60 in, 60 only has 2 2's, so it means my greatest common factor is 2 squared, which is 4. So you're looking for common factor first, and then the largest amount of times it appears in each one of the numbers. In this case, it's just 2 squared. So there's a full video on LCM and GCF, but this was a short one just to do a couple quick examples for you. Thanks so much.